So hello guys, hope you all are doing well, and today we will be solving a new problem, that is a grid game. Yeah, so it is a part of daily questions of Leetcode. Actually it was released 2 or 3 days before. So what this question states is, it is a grid game problem, okay, and it states as like you are given a 2D matrix and there are only two rows and there can be a number of columns. So this is the question. Here, let us see this. So in the it is saying that there are two players. First, it is saying that there is a matrix of two rows and n columns, and then it is saying that for each cell there is some points mentioned. There is some certain number is mentioned. That is some point are mentioned. Okay, and then it is saying there are two players. So there are two players or there are two robots. Anything. So they can move either in the right side or in the down. There are only two options for any of the robot to move, either on the right or in the down. So let us see on this whiteboard. So user can either move in the right or down, and the robot has to move from the 0, 0th column, that is this, to 1. Okay, so the very first cell to the last cell, that is 1 comma n minus 1. Okay, so each robot has to move from 0, 0 to 1 comma n minus 1. So the problem here is that the first there are two robots and each one wants to win the game. That is, it is a game actually. And what the robots will do, the first robot will move in the matrix from 0, 0 to 1 comma n minus 1 in such a way that it will collect each and every point in its path and make it each of the point, it will make each of the point as 0, and it will go on moving from each of the path and it will make each of the point as 0. And after that the second robot will be moving. Okay, and so after the moving, second robot will be moving, and the second robot has to maximize its score. Okay, after first has moved, and the first robot has to uh, take a path in such a way that uh, it's the another robot's score gets minimized. Okay, let's just read this sentence. The first robot wants to minimize the number of points collected by the second points. Okay, the question is not that the first has to maximize its score. It has to minimize the score of second robot. Okay, and also the second robot wants to maximize its score. So so this is the problem. So what, and we have to return like uh, what would be the score of second robot. We have to return that. So so you must be, for solving this problem you must be thinking that if we can maximize the score of first robot, then automatically the score of second robot would get reduced. But this is not the case. This will not actually solve the problem. Let us see with the example. I have already made that example here. So suppose this is the grid. Okay, let me suppose this is a question. Okay, so what will happen here? Suppose the first robot goes. So what you are thinking, that if the robot first maximizes its score, then automatically the second will get the minimum score. So we are checking out if this case will solve our problem or not. Okay, suppose the first so the first robot will try to maximize its score. So in this 2D matrix, what will be the maximum score path? So the maximum score path will be this one. It is very much clear that this would be the maximum path score. Okay, and after that he will move downward. So so it can move like this. So what would be the score of first player? So if that is the case, the first player's score would be 15 plus 15 plus 6, that is 36. Okay. Now let us come to second player. Now second player will again try to maximize its score. So in which direction will it move? It will move in this direction. Okay. First in this direction, then in this direction. Because after first player moves from first path, all the points will become zero. So to maximize its score, the second player will move in the second row. So what would be the score for the second player? Let's see. Second player will get a score of 30, but here it is getting a score of 30. But what actually the question is saying? The question is saying that the first player has to move in such a way that the score of second player gets minimized. Okay, first player has to move in such a way that the score of second player should get minimized. Okay, so let's see what could be another on contradiction to this. Let's first copy this so that this does not get removed. Okay, let's first copy this. So actually I am new to this software, so there was some problem. I think it was already copied. Okay, okay, it's copied. So now let's go back. Okay, so that was one case, or we can do something like this only. Or okay, so now suppose the first player moves in something like this. Let me first paste here. Okay, so this was the score when we are considering the uh, first way. Okay, now suppose the first player moves in this direction first. Okay, in this direction first it moves in this direction, and after that suppose it moves in this direction. Okay, and after that suppose it moves in this direction. So now what would be the score of first player? Let's see. So now in this case the first player's score would be only 30. Okay, but what would be the second player's score? That is interesting here. So now see. So this boat will become zero. Okay, this boat 15 will become zero. So the now now the second player would try to maximize its score. So what will he try? It will try to go in something like this path, because only first 15 is zero, the second 15 is yet remaining, or because in this part there is only 115, but in this part there is 115 and 6 also, so the total score will become 21. So the second player, what it will do, it will move in this direction, simple, and after that it would move in this direction. So what would be the score of second player in that case? Easy guys, you can say yourself. So it would be 21. 15 plus 6, that is 21. That will be the score of second player. So what you can see is that if first player maximizes its score, it does not guarantee that the second player's score will get minimized. Okay, you have to check the path, whether which path is the optimal. So that is so what would be the another way to solve, what would be the best way to solve this problem? Okay, so let's see. So let us check out how it would be solved, this question, how we will solve this question, because the first method is not working. So now suppose this is the matrix. Okay, now what could be the different path that first player can go? Suppose the first player follows this path. Okay, wait for some time. It is having some problem. Suppose the um, let's suppose this. Suppose the first path. So what I am saying was, suppose the first player follows this path. It follows like this, then it goes like this, then it goes like this. This could be one of the condition. So if the first player follows this path, what would be the matrix after it follows its path? It would be something like this. Okay, all the elements would be zero, and the second player will be left with this path. Okay, because only the points would be remaining in this point path. In the second row, all will be zero. So so in this case, the first will be either it would to win, you will have to move in the first row directly. Okay, so this was the first condition. Let us suppose for the second condition. What would be the second condition? Second condition is that the first player can move like this, then it can move like this, then it can move like this. So in that case, what would be the remaining to the after moving in the path? It would consume all the points. So what would be the point after it has moved? So so the in that case, the points would be something like this. It would be something like, wait for some time, the point would be something like this. The remaining array would be something like this. So so in that case the okay, for wait for some time. So in that case, the array would be remaining something like this, and the the second player would be left either with to move with something like this, because there is one point remaining here. So it can win by moving in this path, or it can move by going in this path. And the first point is already zero. Okay, so are you able to make institution here? Either it is taking whole points of first row or the second row. Let us take another example. Suppose the first player goes till here, then it goes till here, and then it goes till here. Okay, so in that case, what would be the matrix remaining? It would be something like this. So in that case, what would be the points for the second player? So either this one will be the point that would be that would be the score of second player, or this point. So you can check out that in each of the case, either it is getting whole of the it can only consume from the either first row or second row. Okay, it is it because the first one is already zero and the last one is already zero. So second player can either consume from the first row, or it can consume from the second row. So this suggests that there is something like there could be something prefix some approach to solve this problem. So there could be some prefix like, okay, so now I think you have understood the question. So now institution, you may be getting the institution for this problem. So now let's discuss the solution. What would be the possible solution? So the solution would be a prefix some solutions, prefix and suffix some solution. Let's check out this in the lead code itself. So suppose, let us take the first example, that is 2, then 5, then 4. So what could the possible solution here? Suppose as from the lead code example itself, the first example says there is 2, 5, and 4, and after that there is 1, then 5, then 1. So what I am saying that I will calculate the prefix sum, that is 2, then what will be the sum 7, then what will be the sum, that is 7 4 11. After that we will calculate the suffix sum, that is from this direction. Okay, so what would be that? That would be equal to 7, then that would be equal to 6, and that would be equal to 1. And this is first 1, then 6, then it is 7. Okay, so what here we will be doing is, first we will be calculating the prefix and the suffix sum, and we will move from I is equal to 0, I, that is I 0 to I is equal to, in this case it will move till 2. So in when it is at 0, what would it will be checking? Suppose when, let us say, when I barabar 0, we will be checking the sub at I will be 0, we will be checking at each point that what will happen if the first robot um, changes the row in that ith index. Suppose in the ith index it changes the row. So what would be its score? Its score would be 2 plus 7 plus 6 plus 1. That would be the score of first player. That is equal to how much? 16. And what would be then the maximum score for second player? That will be 7 plus 11. That is 18. Okay. Now for I is equal to 1, what would be the score for if the first player changes the row, that is from first row it changes to the second row uh, in the I is equal to 1th index, then what the score, that is 2 plus 7 plus 6 plus 1, that is equal to how much? 2761, that is equal to again 16. And what will the score of second player in that case? So 2761 will become 0. So the second player had to take either from the first row or second row. That would be, so the maximum score will be 11. Now let us suppose I is equal to 2. Now if the first player moves the second row in the last index, that is the second index. So what will the score of first player, that is 2 plus 7 plus 11 plus 1, that is equal to how much? 21. And what would be the score of second player in that case? So the maximum score for the second player would be equal to 7 plus 6, that is equal to how much? Uh, that is equal to 13. Am I correct? So, so the first player will always try to minimize the score of second player. So which is the minimum score of second player? It's clearly at I barabar 1. Clearly at I barabar 1 is the minimum score. So this is the solution for this problem. You can solve with your own. I will show you the code snippet for the C++ code, and I will explain. So let me stop the recording, and I will show you the code snippet after solving the question. So now I have solved the problem. Let me show you the code snippet. So what I am doing here is, it is given a matrix. So first I am calculating the size of the number of columns, because number of columns are not fixed. And I am creating another matrix with uh, the type as long. Okay, and I am copying all the elements from matrix to the grid. Now I will perform all the actions in the second matrix, that is grid. So first what I am doing is I am calculating the prefix sum for the first row, and suffix sum for the second row. Okay, and I am taking another variable, that is score, that will be storing the score of second player. After that, I am running a loop for from 1 to n. N is the I is the that point of that column of row where first player will cross the boundary. That is, it will move to the second row. So inside this loop, what I am doing, I have created another very long connection. So now to to manage the edge cases, I have created three cases. That is, first if I is equal to 0, second is if I is equal to n minus 1, and third is in any other cases. Okay, So suppose I is equal to 0. If the first player moves in the second row, if at the I is equal to 0 itself, so what would be the score? The score would be the sum of first row, okay, leaving the first element. So that's what I have done. I have found the point, that is the number in the last index of the grid, because grid contains the prefix sum. Okay, and I have subtracted the point from the very first cell of that row. So this would be the current sum, and that would be the maximum score for the second player in that case. Now, similarly, suppose the case is for the n minus 1th index. What will happen here is, if it is n minus 1th, then the whole first row will become 0, and the second row will only contain the point. So what I have done is, and the second row also has suffix sum. So I have taken the very first index and subtracted the last index, because last index is taken by the first player. So that will become 0. So I have subtracted, and this would be the sum for the second player. Okay. And now suppose else, the player changes the row in any in between 0th and n minus 1th index. So in that case, either the first player will be taking the first row, all the elements of first row, or it will be taking all the elements of second row. And so also the second player will take maximum of both of them. So that's what we are doing. We are taking the maximum of either first row or second row. Okay. And after that, um, now, the first player has to minimize the score of second player. So, okay, so it would change the row in that index that will minimize the score of second player. So that's why for each index, each column index, we are calculating the score, and we are storing the minimum score. So that minimum score would be the answer, and we are returning the score. So this was the question, and it was running pretty well. You have to check some of the condition for long and int, that is integer overflow. The rest, it is a pretty good problem. Okay, so thank you guys.